What's up, everybody? Welcome back. Today we're writing a markdown renderer because I feel like it. Um, Context is a friend is started using my TV tracker. Uh, this is our TV tracker. Ooh, he looks like shit in dark mode, but we'll ignore that for now. But you know, one of the things this thing does is it allows you to set like ratings. You might like stop watching a show. It tracks kind of like how far in you are. It lets you like pause things that like when new episodes come out, you don't keep watching because you're just like, God damn it, this is like annoying. I don't want to watch this garbage, right? And so like you might do something criminal like stop watching Arcane, right? And in here, it might be nice to kind of have some notes because it feels like I shouldn't have done that, right? And so if I go back and say like had a notes field that would like let me say like my thoughts on the show, I could say like why did I stop watching, and then also I could like put other things like what did I like about it, what didn't I like about it, blah blah blah. And so yeah, that's what my friend suggested. I like the idea. I feel like I use bullet points a lot, and I feel like making the rendered text of the notes look not like shit would probably be nice. So I feel like some sort of like markdown like editing thing, where you can like edit it, you edit it in plain text, but then when you hit save, it like renders in markdown would be nice. And I don't know what a markdown renderer does, so I wanted to find out. So that's the plan. Let's make a markdown render. So we're gonna like plan of action is set up a playground, make some markdown, generate some HTML, and then we'll see where it goes from there. Let's I guess start by looking up like the markdown spec. I don't really know who is in charge of this thing. Uh, internet media type text markdown. Who's like, you know, who's in charge of this thing? Who can tell us exactly what we're supposed to do? See also, implementations, lightweight markup language, GitHub flavored. Okay, so these are variants. No 1.0 spec has been released. In the name of this effort, it was rebranded as CommonMark. CommonMark.org has several versions of the spec. Okay, so we start there. I guess we can start here. Spec. 2024 specification. Ooh, test cases. That's kind of hype. What's in here? It's like a little JSON blob that says, given some shit. Okay, that's kind of nice. Given some input, what am I supposed to output in HTML? That's kind of hype. Cool. What does their spec say? What does their spec say? What is Markdown? Why is a spec needed? that's a crazy thing to put. Why do we need a specification for this like language that we've written? Okay, cool. This looks like it has everything we need. This looks like it has everything we need. Let's start, get somewhere we can start writing some code. Markdown renderer. Zig init. And this thing we don't need. We can delete all these comments. Who gives a fuck? We don't need this lib. Everything down here goes away. We do want to build and install this exe though. Okay, and then in here we have, this thing that we don't need, main. We can just do return error, hi mom. And get in it, zig builds. Let's see what happens here. Gruber, the original author, has a very informal spec too. Hype. Hype out. Okay, cool. Hi, mom. I guess we should just write some markdown. Or start running a parser. So in fact, let's just kind of rebrand this. We'll say we're starting with parsing markdown. So I guess we have to like open a file. Std fs current working directory, open file, testmd, I guess. I guess we are going to read to the end with some allocator. I suspect that we should be able to get away with an arena allocator for now. So let's try that. Oh, I actually know that read to end alloc actually does use a uses array list under the hood, which can get kind of expensive. So let's do this. Okay. So here we read with scratch. Data is this, and then we actually like arena allocator duplicate it out, which is kind of funny. You know, whatever. And then here we scratch reset or something. Doesn't really matter. I'm just playing around. Okay. There we go. I guess that's how we do it. That's how we would do this. Okay, so we have markdown content, and now I guess we figure it out from here. I guess we start by printing it. All right. So he's gonna get mad that first he's gonna get mad that read to end alloc didn't give me a max size. So let's say 1 megabyte. Might want to do the dupe before the reset. God, you're such a nag. But you're right. You're right. Scratch data. This thing needs a try. This thing needs this. All right. File not found. So let's do a little like sum title. I guess really copying our stream to do for today is a good place to start. Okay, there we go. So I guess we have to start parsing this thing now. I guess. So how are we gonna do this? Markdown parser. I suspect that you can do this kind of single pass. I suspect that you can just kind of like move forwards, and I expect you can kind of probably like emit tokens, right? So like we're expecting this to be a title, right? We're expecting like title, then stuff, then bullet, then stuff, then bullet, then stuff. So I guess like what we're kind of generating is a tree, right? Like you have like the tree of stuff that you get generated here is like title, and then from as a sub thing of title you have quick and dirty markdown renderer, right? And this is going to be like text or something, right? Then we have like bullet, and then like the text in here is like kind of part of the bullet, right? Then down here we have like title 2, heading 2, blah blah blah. Then we have like, if we were to do it like this, in fact we should do it like that, then we have like checkbox, I guess. Not with full support, or you probably could, but you'll need 2 pointers to backtrack if validation fails. I see. Maybe we like, it feels like Elixir kind of makes sense here. So like, I expect things are probably line based. I don't really know, to be honest. But like, okay, so let's start with like titles. So is it that like a title goes to the end of a line? Do they have like kind of like the parsing, like the parser state, or whatever the fuck, the grammar? That's what I'm looking for. Preliminaries. Characters and lines, tabs. Okay. A line is a sequence of 0 or more characters. Line ending, blah, 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 is called a blank line. Sure, none of this stuff is crazy. Control character. Sure, punctuation character. Okay, cool. Tabs. Tabs in lines are not expanded to spaces. However, in context or spaces help to define block structure. Blah, blah, blah. Okay, I don't give a fuck. Don't give a fuck about escapes right now, although I probably will in the future. References. I really don't care about that. Give me like fucking like just give me like the grammar for like heading. Where's the like fucking pound sign? Is it not even here? Here we go. Here's one here. So they definitely have it. Dude, this is so... I obviously don't care about HTML blocks right now. Am I crazy? Where do they just like tell me what the fuck a header looks like? Dude. Container blocks and leaf blocks. Like, heading. I feel like I'm like losing my mind. Heading. Like, do they not just have like a list somewhere of like all of the things that they support? Oh, ATX headings. Here we go. This is what I was looking for. ATX heading consists of a string of characters, parses inline content. Between an opening sequence of 1 to 6 of these guys and an optional closing sequence of any number of unescaped this. The opening sequence must be followed by spaces or tabs or end of line. The optional closing sequence must be preceded by spaces or tabs and may be followed by spaces or tabs only. Opening character may be preceded by up to 3 spaces of indentation. The raw contents of the heading are stripped of leading original ATX implementation. So it's basically just like you get shit to end of line, right? That's basically what they're saying here, I think, in a lot of words. So let's start there. Let's start there. So I guess like what's concerning is that like whatever we decide to do here like might fall over as we start getting into like the more advanced cases. But I guess that's kind of like just the workflow that we're going to hit. We're going to try some stuff. If it doesn't work, we deal with it later. So let's just start with the heading. So I guess what do I kind of feel like is like a reasonable interface here? I want to like get the next thing over and over again, right? From like externally, I just want like markdown thing. And so far, I haven't seen anything that looks like it actually needs the nesting. I don't think. We might decide later that this is like kind of a lexer and we are going to build some tree, but I don't really think at this point I feel like we need any tree structures. So just kind of doing it flat feels right to me. And so we can kind of say that we're going to have like header start with like how many, or I guess it was called, what did they call it? They call it ATX heading start of this like level. Then we're probably going to want like an ATX heading end at this level. And then we're going to want like text content. This is kind of how I feel like makes sense for now, right? So we'll omit header start, heading end, and then text in the between. And then we can easily generate some HTML out of that. That's how it feels reasonable to me right now. Maybe we'll decide later that's not the case. So here, I guess we probably want some sort of like reader, which means that I guess this becomes like a generic type. Okay. You guys are all saying that the text might have formatting, and you guys are right. It would, huh? Probably would. So then we're going to make this guy feel like Elixir, right? In the same way we can do like, bold start, right? And bold end, right? We can kind of do this type of shit as well. It's no big dealio. No big dealio. Um, yeah, we'll do it that way. Seems fine. Okay. So now this guy needs like self. All right. So what are we gonna do? We're gonna like read some stuff. So first of all, how like reasonable are these like Zig readers? Do I want to model this as like a reader thing or something that like works on a buffer of text? Let's see what their readers provide. IO any reader, I think is where the documentation mostly comes from. Okay, so I can like read 1 byte at a time. I can read until. I can read at least. I can read all. Read until with some allocator. Okay. There's also skip. No peak though. So once I've read something, it's like consumed. Once it's read, it's consumed. Okay. So I guess I'm going to have some sort of state. Maybe. Maybe not. Maybe we just read a byte and see what it feels like. You know, byte. So here I probably switch on the byte. And if I see this, I probably go like parse ATX heading start. Right? Surely. I guess here it depends on like where I am though. Right? Like this is only valid at the start of a line. So right now, maybe like if we saw a bold character or an italic character, we would have to end up in like middle of a line. So we can't really just like unconditionally say this, right? This is only true if we are at start of line. So I'm just gonna say like start of line for now. For now. Just to like flag to myself that I know that this is gonna be a problem later. And then I guess we just increment the level of this thing over and over and over again until this thing ends. And then the problem here is that like once it ends, we might like lose. We're gonna like lose this character, right? Because like we're gonna like peak the next character, and it's gonna like run it. We're gonna lose it once we run out of these like these things. So I guess we kind of want like, do they have something that says like peakable in here? Peak, no. Okay, I guess we make our own peakable reader. this guy surely just holds the reader and then like last byte, I guess. Seems reasonable. Seekable stream. I think this guy probably does like actual seeks on the underlying file descriptor. That'd be my guess. FIFO isn't really what I want, I don't think. So I think I'm just gonna keep doing it this way. This seems fine. Yeah. So this is gonna be like read byte is going to look to see if the cache byte is a problem. What do I want? Maybe FIFO is what I want. I kind of feel like I want to like look ahead by some amount and then consume that amount first. Okay, I'm kind of on your side now. Kind of on your side. Yeah. So let's look at the FIFO interface. Right, so I read into destination. I want to like write into the FIFO, I guess. Then I want to like look into this thing by some amount. So it's almost like I want to like write until something happens. Yeah. I want to like write until some amount of shit happens. Then look ahead to see if it hit the condition that I wanted. Then work my way. Then like unwind if it wasn't what I wanted. And then I assume discard here lets me like discard the first count. How is this like implemented under the hood? Because like all I really need for this, I guess, is like a circular buffer. What is this thing? Head count. Sure. Sure, so this is just like a circular buffer. Yeah, fine. Yeah, we can use this. We can use this. So probably static. This is probably fine. Probably. Question is, why are we implementing Markdown and not our own simple specification for streaming purposes? I don't think I understand what you're asking. Okay, yeah. So this means that we're going to try to like populate FIFO, right? And we're probably going to want to populate this thing with some amount of stuff, right? We're probably going to be like max full. Maybe we just allow it to like go to the end of the FIFO no matter what. Since it's a circular buffer, it's free to just kind of like discard stuff later. So being like, this guy consumes as much as he fucking can seems kind of reasonable. So read from the FIFO into dest. Can we like write from a writer? Writer. Then I know there's like something like pumping in here as well. Pump data from reader into writer. Yeah, that's not really what I want. I kind of just want to like write until it's not a problem. Was it like writable slice? I saw something in there. Writable with slice. Returns a writable buffer of at least size items, allocating memory as needed. Returns the first section of writable buffer. Self slice arg? What the fuck is this? Oh, interesting. And then what if I want like the second section as well? What if I just want to be like literally like put as much shit as you can in here? Does that not exist in here? My dog is like so hyper right now. She's just like running around. That's so annoying. Yeah, it doesn't really feel like this is what I want. I feel like we can just make something that's what we want easier. Right? Because what I want is I want something that's just like put as much shit as will fit into this thing and then let me pull from it as I need. Oh, pretty. It's a golden doodle. She's very adorable. Yeah, I'm just gonna do this. I'm just gonna do this. Tail. Head and tail, or head and count. Sure. Okay. Then we're going to, like, fill from reader. That's all I want in here. Right? So we're going to take in some reader of any type. We're going to take self. And here we're going to, I guess, try to take the first segment. So we're going to look at like buff from head onwards. Quiet down. We're going to go like this. Reader, read. Is it read all? Probably fine. Returns the number of bytes read. If the number read is smaller than buffer length, it means the stream reached the end. Reaching the end of the stream is not an error condition. Yeah, okay. Okay, and then I guess it's like self count plus equals this. That means that this can't happen. So we need like tail. Yeah, we need tail here. And this is going to return self head plus self count mod buff size. Okay. So this is, I guess we call it T because we can't duplicate this. Or we can call this calc tail, which means that we can call this tail the name collision. I guess if tail is greater than head, we if tail is greater than head, we read from head to tail and increment the count. Yep. If head is equal to tail, I guess if count is greater than or equal to self buff len, we return, there's nothing to do. And then if tail is less than self head, we have to read in two chunks. So we first read to the end, then we read from 0 to the tail. Yeah. Yeah. Seems good. Yeah. I don't think there's one there. Then this guy gets a circular buffer here. Read buff. And there's, I guess we need to initialize this guy. And this is actually going to come from external. Markdown parser. Yeah. So this is going to return a markdown parser with type of reader. And I guess we'll have like our buffer here as well. Bucket. So we're going to return. What's the difference between the star circular buffer and circular buffer without the star for functions? One is like take by copy, which is essentially by const pointer, but like you can copy if it's faster. Then the other one is like I'm gonna mutate myself, so I need a pointer because you can't mutate by default in this language. You can't like mutate arguments. Read buff is equal to read buff like this, and then was there nothing? State is auto determined, so cool. So now we can do like self read buff fill from reader, which means that we can look ahead now with no big dealio. Right. So what are we gonna do now? We're going to like look into this thing by some amount. So probably some sort of like iterator here. Makes sense. Right, so we have like our parent is our circular buffer. And then we're gonna go like, this is gonna give me some U8. Yep. And we're gonna like if self index is equal to self parent count, probably greater than or equal to just in case. Return null. Defer self index plus equals 1, and then we look at self parent head plus self index percent self parent buff len. There we go. There we go. Okay. Now we just need to like make this guy make one of these things. Probably by const reference is fine here. And then we go return parent is equal to self. Yeah. Cool. Okay. So we fill this from our reader. Then we can like make an iterator out of this thing. And we can go give me, or else return null, probably. If we have nothing to read, then we have nothing to read. Seems reasonable. He doesn't seem to like this for some reason, this next function. Probably because this doesn't return the iterator. There we go. And now we can say, let's parse this thing and let's pass the iterator down. So that we can remember how far we're into this thing. Seems reasonable. Seems reasonable to me. Okay, so now what are we going to do? We are going to find the, like, we're going to look forward until we find something that is not this thing. I think that what were the rules? Is like 1 to 6 of these guys, I believe is what they said. 1 to 6 of these must be followed by spaces or tabs or by end of line. Like followed by end of line. By space, tab, end of line. Okay. Then I'm just not gonna do the closing sequence. I don't give a fuck. Raw contents are stripped. Yeah, okay. So I guess we're going to say while it next if some byte, if byte is not equal to this thing, break, else we do num num hashes, I guess we'll call it, plus equals 1. Assumed this is called after finding 1. I think that's fine for now. Then we increment num hashes, and eventually we're like, uh-oh. So if num hashes is equal to 6, break, and we'll say no more than 6 allowed, then we can check that it next, if this here we say if byte, like, I guess ASCII is white space byte, we're good. But if this is not, then we return false. So we say, like, maybe we need like some sort of like ATX heading result, right? So like either this succeeded and this is in fact an ATX heading, and we need to say how many elements there were in that heading. Otherwise it's failure. But failure is not like failure, so I don't want to flag this as like an error. I guess we could do this as like a U size, so we could say that this is, we might get some amount, which I think is fine. That seems okay. So this will turn null. Otherwise, we consider this a success. And we consume however many bytes of this thing we had. So we want like self, read buff, consume it index. Right? This is how much stuff we read. So we need to implement a consume here. Amount. And we're going to say self head plus equals amount, or no, self count minus equals amount. Head stays in the same place. And is that right? I think that's right. I don't think there's anything else we have to do there. And we also have to make sure that when we increment, we're never incrementing head here. That's really bad. Red bytes is this. So we're gonna say self advance head by raid bytes. Var red bytes is equal to this. Red bytes plus equals this. And then I guess we can probably do it like this, so the count gets kind of put in there as well. Amount is U size here. Okay, so we take the count and plus equals amount, simple, right? And then it's self head plus equals amount as well. And then we also have to like heal this thing. So I think that that's right. I think that's right. We'll see. And then our consume is literally just subtract the count, which is simple. Yeah, okay. So we don't know how to deal with anything else. And if this succeeds, we probably want to do like return num hashes. So we probably want this to be like, we want to like fall through somehow. So I guess it's more like an if statement here. We try this. And then I think that like, num hashes. So if we get this thing, we return ATX heading start. And then if this fails, then we're going to have to do some other work. We're probably going to have to like reset the iterator here. So it's almost like we want to clone it on the way in. So that anything that like we do here like undoes itself automatically. So that we can try something else after. Right? So maybe we take an IT const here and then we say like let it is equal to it const. Sorry, var in this language. Yeah. And now we don't have to worry about like undoing it, which is kind of sick. All right. Maybe we just assume text for anything else. Oh, I guess we also, if self state is equal to start of line. Forgot that part. And I guess in reality, we should probably, I guess all of this should like go inside of this almost. Like it's almost like we just want to try in order because we don't really know, like we don't know if we're at a point at this point where we should be parsing an ATX setting start. So I think it makes sense for us to just try it. So we just say like, if we get this thing, we're chilling. Then here we're like, if we're not at the beginning of a line, we back the fuck up, right? Then we probably also check, like, we probably want like consume white space, right? Because I think that's what it said here. The opening sequence must be followed by, or no, it has to be start of line. Oh, this seems to be allowing it. Between an opening sequence of 1 to 6 unescaped and a closing sequence, you need to track indentation at the block level. Oh, gross. Okay. So block. However, in context where space help to find block structure, blah blah blah. I want to know like ATX headings. So these are leaf blocks, blocks and inlines. We can think of a document as a sequence of blocks, structural elements like paragraphs, block quotations, lists, headings, rules, and code blocks. Some blocks contain other blocks. Others contain inline content. Okay. Indicators of block structure always take precedence over indicators of inline structure. So for example, the following is a list with 2 items, not a list with an item containing a code span. Okay. This means that parsing can proceed in 2 steps. First, the block structure of the document can be discerned. Second, text lines inside paragraphs. Okay, we can divide blocks into 2 types. Container blocks, which contain other blocks, and leaf blocks. So the ATX shit is a leaf block. Yeah. And so we are going to assume for now that we are always at a leaf block at this point. A container block is a block that has other blocks as contents. There are 2 types of container blocks, block quotes, and list items. Lists are meta containers for list items. Oopsies. Didn't mean to click that. Yeah, I'm going to just assume for now. We can come back to this. We can come back to this, but we can assume for now that we're going to start with these things. We also don't have to be perfect, because I don't know if I really want like a fully compliant markdown parser. Okay. So here we have to say like if num hashes equals 0, then we failed. And then I think we're chilling. Okay. We'll start here and see what happens. So we're hoping to see that if we have this like file and we say, get me a reader, and then we're like, make me a parser. Can we just literally do like parser buff is this? Seems reasonable. Okay, and then we're gonna do parser next, and we're hoping that this is going to be a ATX heading start, right? Because we're parsing the thing that's on the right side of the screen. Okay. This thing is pissed because parser next. Oh, is it try parser next? Okay. Then parser needs to be var here probably as well. Okay, red bytes 15. Okay. Value of view size ignored. True. We do have to return things and then consume white space. Doesn't exist yet, so we'll just ignore that. Num hashes needs to know it's a U size. And is white space here. I guess this cannot be a header if there's no thing at the end. Okay, so we hit unreachable, which is not good. That's not good. I think we need to understand why. I guess we probably want to start on here, and we're gonna have to figure out which of like the tons of code we wrote is wrong. So first of all, let's look at self-read buff here. So it looks like we have count 0 here, which is not good. Right? That seems pretty bad. So it's because we have a self-tail equals self-head. So that's this case here. Okay. Does that work right now? Okay, so now this looks about right. Our count is 256, or 286. Our head is 286, and that seems correct. Oh, oops, I should have done step. Okay, so here we get into this thing. Can I print this as like a... How do I fucking print this as a like ASCII? GDB print as character. Print as single character. Am I fucking stupid? Help P. Like, I know that you can do like PX here. Oh, which he seems pretty unhappy about, huh? That is definitely not right. Right, because we're supposed to start at the tail, not at the head. Yeah. We are just reading from the wrong fucking side. Okay. Still 170. That's not good. Did I build? I did. Is this wrong? Self head. No, this is stupid. Minus self count. And then this is a problem because this is going to go the wrong way. Like, this is going to underflow. So this is plus self buff len here. Then this goes backwards. Let's try that. It's probably easier if we go like this. All right. So we got a hash this time. That's good. So then something else happened. Can we run this again? But actually follow this now? Okay, so we got one. But then we got something that's not that? Oh, wait, that makes sense. Okay, right, because we got the space. Oh, so it's that here we got something that's not a space, and then we need to look at that thing that's not a space here. So this has to come up here after the read, and then it's actually like we want to do something like this. While true, we say byte is equal to it next. And then that allows us to this is probably return null here. If we don't get the thing out of it, then it's like unexpected. So if we, yeah, that seems right. If we have over 6, then we give up. If it's not one of these, we break up or give up. I think this might come first. So let's think about the sequence here. We get 1. We say, okay, now we're at 1. If the limit was 1, we would break now without reading the next. But I think we do want to read the next. So I think it's like this. Then we have the next thing cached in the byte here. So then we check here if it's white space. There we go. That seems kind of right. There we go. We got our fucking ATX heading start, baby. Okay. So now if we were to go into our test and say 3, 4, 5, 6, this should still succeed with 6, which it does. And if we put a 7th in here, it should fail. Nice. Nice! All right. So we are fucking an hour in, and we have parsed the first character. Let's fucking go. Okay. So I guess we eventually are going to say parse like the inside of this thing, right? So we want to like parse text until header end, which means that we kind of have to know that we're in a header, right? Otherwise, like, because if you just had like tons of stuff in here, right? If we had like, say we were like, just like, you know, we have like tons of this stuff, right? This should, I think, all get parsed as like one single chunk of text. I think. Maybe doing it line by line isn't the end of the world. If we do it line by line, I think that makes our lives easier for now. So let's do it that way, and then we can discover the problems with that later. So we're gonna say like parse like line as text. Yeah. I think that seems reasonable. So here we are going to read until the end of a line. We're gonna like while IT next. We have to be careful here because the text that we output needs to live somewhere. So we could say that whoever wants this text will pass in an allocator, and that's where the text will live. And then the other option is that we kind of stash it here. But then if you have like a line that's really long, that wouldn't work. So I'm kind of feel like it's easiest for now. I mean, this might not be like the most efficient, and maybe we'll kind of change our minds later. But I think I kind of want them to pass in an allocator here. I guess technically, yeah, that's fine. So we're going to, in a loop, we're going to loop because we might run out of text in this really long line, right? We might run out of text. And so we're going to basically consume the whole FIFO while we can. Then we're going to try to fill this guy back the fuck up. Uh-huh. And then while we go through each thing, we have some byte. And if like is new line. I know that Greyhatter was saying that I can't just do this, but I'm just gonna do this. You can't stop me. If the byte is a new line, then we're done. Okay. You said that I can't just compare with new lines. I'm pretty sure you said that somewhere. But I'm just gonna do it anyways. You can't stop me. So if we're gonna call this scratch. Let me think for a sec. So we need to know. So our like linear FIFO has like up to 496 bytes in it. We are going to like read some amount. It means that we are like kind of we're getting this in stages, which is annoying. We like don't know how long the content is gonna be until we like get to the end of it. But if we can just like seek backwards, that's like kind of okay. Yeah. If we could, if our reader had seek on it, then we could just move it back and read it again. Which is not ideal. It's not single pass, but it's also not the end of the world. So how do we like get one of these? Like this thing has seek by and seek to. So we can like get our initial position from the reader, which we don't even really know. Ugh. We can do it this way. It's fine. This is fine. Okay, line as text is... I think that this thing can't fail. Unless, like, allocations fail. So we kind of do something like this. If we get here... We probably want to, like, keep track of, like, where we started. Then we, like, read, and if we get out here... If we see a new line, we append slice of... I guess we want to do, like... read to slice. Yeah. And we want to go from, like... some start position to some end position. And this is going to... Or, like, get slices. Yeah. This feels like it works. So here we go, like... We get the tail, probably. And, like, if head is less than tail... Oh, we have, like, the special case here of count is 0. This is, like, both of these guys are empty. There's nothing to fucking do. If head is... If tail is greater than head, then we just return one slice. It's just head to tail. Okay. Otherwise, it's 2 slices. Wait, is this backwards? This is on read. This is the wrong way. Yeah. It's the other way on read. So you go from the tail to the head. And then in this case, it's tail to the end and 0 to the head. Yeah, something like this. Something like this. There's a good chance that we got something wrong here, but it's okay. So then we can say, like, give me the slices from IT start to IT index. And then we do, like, we put them in here, like this. Okay, and now we just have to determine, then we unconditionally reset, right? So this should kind of be like a return right here. We only ever return if we see the new line. Probably. There's probably some sort of like end of file shit we have to deal with here as well. But for now, we're assuming, I guess if this thing happens, if we fill from the buffer and then we're still empty, then we also return ret to own slice. Yeah. Okay, that seems kind of reasonable. Then here we still have to do one last copy. Which means that, like, surely this stuff is, like, dedupe with below. But I'm okay with it for now. Okay, so now like we have 4096 chunks. We probably read them in order, probably, and we probably exit at the right times. Unused parameter end, huh? Yeah, it does seem like we just didn't use start and end, huh? So we should be looking at like start index. Start buff index is tail plus start, and we need to look at this like this. End buff index is end here. And then here we should be using this only comes after we check if it's literally empty. If count equals 0 here. Okay. Then it's everywhere we're using tail, it's start buff index and end buff index here. This is start buff index, end buff index, start buff index, end buff index. Okay. That's like a maybe. That's like a maybe that works. Parser next at 198. Okay, so now we probably want to do this in a loop. And I think we want to use the scratch allocator here. Okay. Fuck it. We can retain. That's fine. And then here we want to use... Actually, free is fine. We want the parser to be here. And then we want to print next. Okay. Cool. Okay, what's he pissed about now? This, probably. He wants the allocator. Fill from reader is an arrowable thing that we are not respecting. And it looks like this is not behaving the way I want it. All right, let's see why. Surely it's just that we're not advancing. In fact, I can tell we're not advancing. So we want to do this. And probably here as well. Yeah. He is still not successfully getting out. But it does seem like the text is now empty, which is pretty good. So we probably just need to check here on like on the entry to the parser. If the count is equal to 0 after we try to fill them out, we return null. We're donezo. No more parsing to do. Okay? And then here we need to do while try parser next. Here we just have to get a little more clever. So if we say elem is parser next with the scratch allocator, or else break. Okay, then we switch on the elem. And we can start like rendering this thing out, I guess. So if we have like start, ATX heading start. With some count, I guess we'll just log header with this many, like this level. Okay, and then otherwise we render the text. Okay. And can we render this as a line? Maybe we call this line. I think that's clearer. Okay. That feels like it might work. ATX heading end. I think fuck ATX heading end, to be honest. We might not even need it if we're going line by line. If the thing has a new line in it, I think we do not want to count the new line as part of the thing. So I think here it's IDX -1, and then we... Okay, that's looking pretty good. So we have header with 1, and then everything else. Nothing else is like, all of this is getting turned into text, but that's fine for now. So now we can probably start like turning this into some HTML. So I guess literally all we've done in all of this code is parse markdown headers. That's literally it. And now we can generate HTML with ATX headers. Okay, and then we'll loop back for more in a minute. So let's make some sort of output file. Okay. Probably need to close this. And we probably have something like writer here. And I guess here, we probably want to keep track of like, for each line, is there like some closing tag that we need to do? So let's say that we have some like line end. And this is just going to be an empty string. And here we're going to write out the line end after. We're going to ignore like escaping of HTML characters for now, but we are going to have to do that as well. Escape, please. Okay, so if we see a header, then I guess we are going to inject the appropriate header, right? So we're going to be like, writer print some opening tag with some number. I assume it's like something like this, right? Then we're going to write we're going to say that the line end is equal to, you know, this. Which means that this guy has to be some sort of like type that will, you know, clean himself up. We've got like some sort of like cache type here. So we're going to make this like a stood bounded array of U8 with, you know, 100 bytes or something. Surely we don't need more than that. Then we go line end append slice of this. But here we actually want to buff print into this guy. So we're gonna do stood format alloc print into the scratch allocator, I guess. I mean, maybe that's not ideal, but this will work for now. Temp end HD like this, and with count. Okay. Then we append the slice of temp end. And this goes away. Okay. Then here we write out the content, which is simple. And then what? We might put a BR in there. I'm not really sure, like a little like intentional line break. We might not. And then we write out the line end. And then we reset Is there no, like, clear? Fine, we'll resize 0. Alright. What's he bitch about? Append slice. Line end. Alright, it's like items or something. Alright. Let's see what we got out. So we did get a nice little header here, but then everything is in one line, which kind of blows. So first of all, let's do this. And we can put the new lines in ourselves for now, I guess. Not that I think that, like, it really fixes the problem. But now at least we have this. Now what happens if we, like, open this thing? I assume that this looks like shit. Yeah. So we do have this, and we do have the plan here. So we have two nice little bolded lines. That's pretty hype, but this is shit now. So I think in Markdown, you're only supposed to inject a new line if you have a double empty line, or like an empty line. So it's actually kind of behaving correctly for now. It's just that we haven't implemented like these like bullet point things right now. So let's just do that next. So we try parsing this thing. If this doesn't fail, we have to think about like if we're in a list. There are also new lines, not new paragraph. You have two spaces at the end of a line. Oh, wait, isn't that what I was talking about? I think that's what I was talking about. Okay. So they were talking about like, I guess when you do like HTML, you have like blocks of lists, right? So, right, when we render the HTML for this thing, what does the HTML look like? You have to create an unordered list first, right? And you have to know to end that thing. So that means that we need to say that we're like in list. I think. And like, maybe we use unknown instead of end of line or something. Or like, you know, default maybe is better for this. So we're either in default or in list, right? And so like, if we are in a list, then we have to check if we are exiting the list. Probably by looking for like an empty line or something. Which means that this guy has to emit list start. Or maybe like list elem. And who's list elem, line, and list end. So if we see a list element, we know that we have to start our list. Then we see a list end. I'm assuming that like maybe there's like nested lists, huh? There probably are. But I think that's probably fine actually. Right? Like as long as we have the same number of list ends to list elements, this should kind of just work. Like this interface. No, we need to find list start. List start, list element, list end. Yeah. And then so if we're in list, we will emit list elements and list end. But if we're out of a list, then we'll try to find a list start. Sure. So here we can return list start. And then if we're in a list, that means we kind of have to handle that case first. Or maybe like we kind of behave differently depending on what state we're in. Right? Like in default, we do these we have like these sort of actions that we're willing to perform. But if we're in list, it's literally just like if we're like at the end, then like get the fuck out. Otherwise, we parse the line. And I guess we might not actually need the list element here. No, we do. So every time we see list element, we like put a bullet down. Then we expect line to like clean that shit up. Then we see list elem line, list elem line, list elem line. It's like the fact that we're in the list kind of like implicitly determines that we like should bullet point every line, right? It kind of feels that way to me. So it kind of feels like we should do this. But then that doesn't really match up with this. And we do still need to parse out the bullet. So I guess we can do it this way. We can do it this way. So if we find a bullet, yeah. Otherwise, then we just pass out the line. I think that makes sense. And so we just have to like implement these functions. Parse list start, parse list end, parse bullet. Okay, for now, I'm not really going to refer to spec here. I'm just going to... Oh, it means that we don't have to check for state in any of these. State's kind of covered at the top level. Okay, so I think parse bullet and parse list start are the same. I think. I believe list elements can be multi-line. Yeah, I know. I'm kind of ignoring that intentionally for now, but I think you're right. Oh, at some point we started looking at bullets. Okay, so list end is literally we're just looking for double new line, right? So that should be easy. It should be like IT next, or else we get an iterator over our read buffer. We get like A is like first and second. Or is it just if we see a new line here? It's probably just if it is new line. Then here we're probably looking for like we probably then want to like we probably want to consume this if it succeeds, right? So this if ret we do, I guess we want like, oh yeah, it's fine. IT self read buff consume 1. Then here for parsing a bullet, we're gonna look for a star at the front. I know that there's more to look at. So if it's not a star, return false. So if it's not a bullet, return false. Then if it's not a space, return false. And this is probably any white space or something. And this is like probably other bullets. You know, then here we kind of consume 2 bytes and return true. Sure, fuck it. I don't know. That seems kind of fine. Okay, so now when we like look at these things, we have like list start. And this is like we write out a UL. And then our end is like the existing end plus another UL. Yeah, so we almost want to do like do something like take the shit that you already had and prepend it with a UL. Something like that. And then we probably wanted to like put a new line in there if it was if the length was 0. Probably something like this. Append it, no? I think prepend. Because it goes on the, like, this is like, if there's multiple of these, like, we need the closing thing to come first. I think. Oh, wait, no. Hold on, I'm a dumbass. Line end doesn't change here. Line end is not affected because this is triggered by list end. It's that we then put in a list item here on line start as well. Yeah, if we have list elem, we put a little one of these guys, and we set the end of the line to be finish this list item. Yeah. Okay, that feels kind of right. Okay, so we got... This doesn't look good. I think we forgot to change the state here. So we want to do in list, and then we go back to default state after this. And then I think that our line end here, we probably want a little new line at the end of him. And then our UL, we probably want a new line at the end of him as well. Probably all of these, to be honest. And then it looks like here we need to end this list item here as well. It's more like UL new line list item. Okay. That's pretty sick. That is pretty sick. All right. Pretty good. So we're definitely not all the way there. But also, My poor dog is like seems to be a little bit worked up. I think she might have to go to the washroom. So I think we call it there. We call it there. World's shittiest markdown parser. We can only parse bullets with stars at the start of line and little hashes to make titles. But I mean, it's something. That's pretty sick. We've got a lot more that would have to be done if we want to do this right. But I think we're also learning. We've also learned enough to be like, wait, this is like, it seems like nice and quick and dirty, and I think it's not that, which is kind of fun. So maybe I just don't want to be markdown compliant, and I want to have my own little shit markup language. We'll see. I don't know how it's gonna go, but we're gonna call it there for the day. Thank you for watching, guys. If you like what you saw, we stream most days at around 4 o'clock or 12:30 Pacific time to 4 o'clock Pacific time. It is 3:30 now, so expect to see us online between 3 hours ago and half an hour from now. Some days we start a little early, some days we end a little late, but it is what it is. There's a YouTube link in the Twitch description where VODs go up. Please consider if you want this content to stay around long term, if you have extra cash to throw around or an Amazon Prime, supporting on Patreon, YouTube members, or here are all ways that you can ensure this content lives for longer. Otherwise, I think that's all we gotta do. YouTube, peace out, and Twitch, let's find someone to raid.